Okay, so in a previous video, I derived spherical coordinates. In this video, I want to derive the line element on a sphere, where these are our previously derived spherical coordinates. Okay, so on a sphere, that basically means that rho is constant. You know, the radius, distance from the origin is constant. That's sort of what it means to be a sphere. So we start with our spherical coordinates, and we'll we'll basically differentiate them. We'll find the differentials of x, y, and z. Now, rho is a constant, so when we're taking the derivative, we can sort of ignore rho, and we only have to consider changes in phi and changes in theta. So that's why you don't see any d rho term, because that'll just be 0. So here is our formulas for the differentials with the multivariable chain rule. Okay, so what do we have our dx, dy, and dz, and our line element ds. You just use the Pythagorean theorem, and you get square root of dx squared plus dy squared plus dz squared. Okay, so I'm not gonna go through all the algebra, because then it'll take way too long. But I'm just gonna show you, just how you could start. Let's go ahead and calculate dx, for example. So we get the derivative with x, the derivative of x with respect to phi. So it will be rho cosine theta, that stays constant, and then sine turns into a cosine phi, and times d phi. Then you add the other part, which is with respect to theta, so you get actually subtract rho sine phi times sine theta right here, and then d theta. So that's just dx, and you have to square that, and you get a similar looking expression for dy, and dz is a little bit simpler. But anyways, you do a bunch of algebra, and you're left with this final line element. And if you can't see that clearly, this is just theta prime. So it's theta, it's a derivative of theta with respect to phi. I decided to pull out the d phi, so you can integrate it with phi. You could also pull out the d theta and integrate with respect to theta. Because the whole reason you're pulling out a line element, you eventually want to integrate it to find, the length of some line on a sphere. But anyways, yeah, that's the line element.